Hi, this is Abhishek. Today I'm presenting my project Stance Detection for Fake News using Deep Learning. This project is submitted as part of University of Florida course EEL 6825 Pattern Recognition. Fake news has been present in the society for a long time, but the recent advancements in new media like Facebook, LinkedIn, Reddit, Twitter have allowed these news to propagate very fastly. Fake news, as defined by Alcott and Genko, is news stories that have no factual basis but are presented as facts. Fake news has many consequences on the society. Researchers have shown that 62% of US adults who see fake news actually believe them. The bigger problem is not only people believe them, they start doubting real news, and that causes confusion. Detecting the veracity of fake news is a very complex task even for human beings. Any attempt at classifying the story as if true or false is bound to be challenged as being biased. Stance detection is the most concrete part in face news detection which we have. Stance detection is where we have a headline and a body and we try to determine whether the headline corresponds to the body. The body can be actually related to the headline or totally unrelated to the headline. If it's related, it can agree to the headline or disagree or just discuss the headline. Fake News Challenge is a public challenge organized by Deli Prau and Max Pomeler. This challenge aims to explore machine learning techniques and automation, especially in natural language processing, to perform the task of stance detection. The challenge is a classification task where we need to classify whether the headline and the body are related, and if it's related, then does it agree or disagree or just discuss the headline. The dataset for the project is provided by the organizers of the challenge. The dataset is available in CSV files. There are two CSV files, stance and body file. The stance file is of the format headline body ID in stance. Headline contains the words corresponding to the headline of the news, and stance is the value determined by journalist to whether this stance agrees or disagrees to the body ID in the stance file. The body file contains the body ID and the article. The articles are around 500 words each. The description of the data is shown in this table where we have 49,972 rows. Out of that, 73% is unrelated and remaining 27%, 17% discusses, 7% agrees, and 1% disagrees. The organizers of the challenge have provided a baseline implementation just to be give an idea of how this project works. This baseline implementation is done using gradient boosting. Gradient boosting is just gradient descent plus boosting. It's an ensemble classifier where the model is built iteratively stage wise, and in each stage of the descent it adds a weak learning for classification. In my project, I'm using RNN and LSTM. RNN and LSTM are the most common machine learning tools being used today. Research has shown that it performs very well on speech recognition, image classification, and text prediction. So I'm trying to explore how it works in this fake news challenge. The input data is in the CSV file, but the system, a model cannot take this CSV file and run the classification on that. You need to extract features, meaningful features, which would help in the task of classification. The baseline implementation does creates hand-coded features using n-grams and char-grams. N-grams simply means we divide the word into size of n. And for this implementation, the words are divided into 2, 3, 4, 5, and 6 size n-grams. It also generates a refuting and polarity vectors. Refuting vector contains words which are kind of negative connotation and determine whether the article and body are related with negation. Polarity vector is for the stance part where we determine whether the stance is negative or positive. In addition to the hand-coded features generated in the baseline implementation, I'm also using a standard word vector called GLOVE. GLOVE is global orientation for global vector for word representation. It's developed by scientists in Stanford and has huge corpus. Coming to the architecture of the system is developed in a modular way where each file and function corresponds to one task and is in separate files. The first step is to read the CSV file and convert into a Python object where it's easier to handle or access each body and stance ID using the ID. So the CSV data is converted into a container called using dataset. Once we have the dataset, it needs to be divided into training and testing set. The one point to focus here is the training and testing division has to be done in a way that we don't spill stances for a headline in training into the test. This is because there are only 1600 unique headlines and those headlines map to around 49,000 bodies. So there is one to many relationship, and if we have a headline in the train set or the test set and we have bodies corresponding to that also in the test set, that might corrupt the data. Once we have the training and testing data set, we generate features on that. The features are generated on both the training and testing set. The training set features will be used for training the system, and for testing the system, the test features will be passed to the trained model. The training and testing data is divided into 80 to 20 ratio, where 80% is used for training and 20% is used for testing purpose. Out of this 80 to 20% of training, we do a k-fold cross validation where we use 10 folds with 80% of training data and 20% validation set. The model is a 3-layered LSTM model which has an input layer, a hidden layer, and an output layer. The model is implemented using Keras sequential model. The LSTM model is activated using linear activation and optimized using an Adam optimizer, which is an efficient stochastic gradient optimizer. The model is trained for 10 epochs. This project is implemented in Python 3. A point to note here is it works only on Python 3 as the data provided by organizers and the methods provided to read the data does not work on Python 2.7. Keras needs TensorFlow or Theano to do this efficient numerical computations. I'm using Theano for now. The baseline implementation uses scikit-learn's gradient boosting classifier to do the classification. The LSTM model is built using Keras sequential model. The results of the project is compared to the baseline gradient boosting classifier using these metrics. Confusion metrics. Confusion metrics comes into picture when we have an unbalanced set. The data we have right now is 73% of that is unrelated. So if we do a classification and the model classifies everything as 100 just unrelated, even then we have a 73% of accuracy, which is kind of misleading. So in that unbalanced scenario, having a confusion matrix helps, as you can see how many of actual data is what's the class of actual data and what's the predicted value. Score is a metric provided by the organizers where it's a weighted metric. 25% of the weight is given to the classification step where the body is related to the headline or unrelated. Once we determine it's related, 75% of the weightage is given to that part where we determine if it agrees, disagrees, or just discusses. In addition to the confusion matrix and score, I evaluated the performance of the model based on training and test speed and memory consumption as well. The results of my experiment show that the time and memory taken by the LSTM model is a bit higher than the gradient boosting classifier, but it's still within limits of the system. I'm running this experiment on my local machine which has 8 GB RAM, so that didn't run out. It needs 45 minutes to train, while the gradient boosting classifier used 26 minutes. The time is not just training time, but it includes the training and testing time on the dataset. Memory used was 200 MB by gradient boosting and around 400 MB by the LSTM model. This table shows the confusion matrix for the data generated, predicted, using, classified using LSTM model, where we see I was able to achieve accuracy of 85%, which is around 5% higher than the accuracy achieved by baseline gradient boosting classifier, which is around 79%. So as part of this experiment, I was able to achieve a 5% improvement using LSTM model while using comparable, while having comparable speed and using same resources. A way to improve the classifier would be a combination of using combination of classifiers. Some people have used like a bag of word classifier for the initial related and unrelated classification, and then use a machine learning classifier like deep learning for the agree, disagree, and discuss part. Another way to improve the classifier would be if we get more data to train and find better features. So that's it for the presentation. Now I'll show my code and do some demo on the run the code. As I said in the results table that it took me, the baseline implementation took around 26 minutes to run. So running that as part of this demo would be making the video too long. So I already ran that code and found the results. So if you see here, this is the number of stances we have in the body, and it does train on iterations, and in the end it prints the confusion matrix and the score. And I ran my LSTM model here. I'm getting some errors somewhere, but still it's working fine. Work in progress. So now if you get back to the code, this is the baseline code where it's stored in 5 files. This FNCK fold py file is the main file where it starts. If you see here, it uses a gradient boosting classifier. So it starts from here. It first checks the Python version, and as I said, it works only on Python 3 as there are some errors on Python 2.7. So it it will be error message. It will throw an error message if we have less than version 3. Then it checks the parameters, and then it builds the training and testing split. So this is k-fold split, which will generate the test. It will, this is 80 and 20% of with n folds. Once we have the training and testing, then it generates features and stores the features if it's already generated. Once you have the features, it goes to, it builds the model and fits this model, and then runs predicts to generate scores. So that would be all for the presentation. Thank you.